We're going to start our look at polar coordinates looking at conversion factors. X and Y in the rectangular coordinate system can be converted to polar coordinates using x equals r times the cosine of theta, y equals r times the sine of theta, where r is the distance from a point to the origin and theta is the angle in standard position that indicates where the point is on the plane. Additionally, we have that x squared plus y squared is equal to r squared, which looks like the Pythagorean theorem because it's basically the Pythagorean theorem with different letters. And the tangent of theta is equal to y over x. Sometimes folks think that this means that the inverse tangent of y over x is equal to theta. That's actually incorrect. The inverse tangent will only give a reference angle. Its answer can be positive or negative, but it's essentially a positive or negative reference angle. So we have to put it in the correct quadrant based on what we know the xy coordinates are. We won't mostly be working with just points, though. We're going to be working with equations and expressions and functions and all that good stuff. But it's still good to know how to plot them. In polar coordinates, a point has the form r theta. For instance, the point 3 pi over 6 has a distance of 3 units from the origin. We call it the pole, and is on a ray that is an angle of pi over 6 with the x-axis. Let's look at a polar grid. A polar grid is a series of concentric circles of radius 1 for the inner one. That would be the unit circle. Radius 2, radius 3, etc. Those radii correspond to the r in the polar coordinates r theta. As far as the theta, they're the angles, and the angles are theta equals 0 for the positive x-axis, theta equals pi over 6, theta equals pi over 3, pi over 2, that sort of thing. And then in this particular grid, we do have theta equals pi over 4. It just doesn't extend all the way down into the middle of our graph. What we've been calling the x-axis is the polar axis in the polar coordinate system. It is still the x-axis. This is the same space that you've been working with. And what we would have called the y-axis is the line theta is equal to pi over 2 because that's the angle made with the positive x-axis. And what we had been calling up till now as the origin is the pole in the polar coordinate system. And the equation of the polar axis is theta equals 0. The point 3 pi over 6 is on a ray that has an angle with the x-axis of pi over 6, and then 3 units out on that ray. And so our point 3 pi over 6 is right here. So 3 units out from the origin and 30 degrees up from the x-axis. Now this angle with the x-axis is a positive pi over 6, but we could also refer to it as negative 11 pi over 6. It's coterminal to that. So this actually can also be written as 3 negative 11 pi over 6. There are actually an infinite number of representations for any point on the polar plane, provided that the radius matches and the angle is coterminal. Now, we math people have been a little bit weird about something here. We're saying that r is a distance from a point to the origin, and it implies that r can't be negative, but r can in fact be negative. If I want to express this same point as this point 3 pi over 6 using a negative r, totally fine, but keep in mind what a negative r does. A negative r essentially jumps over the pole. And so if I want to refer to a negative 3, if the angle that I want to land on is pi over 6, I had to have come from an angle that's 180 degrees away. And that angle is 7 pi over 6. So the angle 7 pi over 6 is in the third quadrant. The negative 3 jumps it 180 degrees and puts it on the angle pi over 6. So the angle negative 3, 7 pi over 6 actually has the same location as 3 comma pi over 6. To see how this is possible, we can refer to our equations. X is equal to r cosine theta, y is equal to r sine theta. In this case here, for 3 pi over 6, x equals 3 times the cosine of pi over 6, y equals 3 times the sine of pi over 6. So x is going to be 3 root 3 over 2, and y is going to be 3 halves. If we use that negative 3, then we'd be saying that x is equal to negative 3 times the cosine of 7 pi over 6, and y is equal to negative 3 times the sine of 7 pi over 6. And you will find that we end up with the same coordinates. Now, to expand a little bit on this idea of this inverse tangent not always giving us an answer that we expect here, remember that the inverse tangent will only give us an answer, an angle, in the first or the fourth quadrant. First quadrant if the argument is negative, or positive. Fourth quadrant if the argument is negative. So suppose I have a point in the third quadrant. We're going to consider, negative 3, negative 4. What the heck? This is in the third quadrant. And it's true that the tangent of theta is equal to negative 3 over negative 4, but the negatives divide out, and so I end up with 3/4. If I use a calculator value, then I'm going to find that the inverse tangent of 3/4 is approximately 37 degrees. That's clearly in the first quadrant. However, the point that I started out with, negative 3, negative 4, is clearly in the third quadrant. So I treat the information that I have, 37 degrees, as a reference angle, knowing that I'm in the third quadrant. And so if we consider this angle here, made with the negative x-axis of 37 degrees, then we see that I need to add 180 degrees in this case. And so here, theta is going to be approximately 217 degrees.